In this session, let us discuss transport layer and UDP protocol. Transport layer. The main responsibility of a transport layer is process to process delivery. That is, system to system delivery is not enough. Host to host, node to node is not enough. We need to deliver the data from process. Process means application program running on the system. So one application program to the other application program on the receiver. It uses mainly three protocols: TCP, Transmission Control Protocol; UDP, User Datagram Protocol; DCCP, Datagram Congestion Control Protocol. Basic unit of data in the transport layer is called segment. It is also referred to as Transport Protocol Data Unit, TPDU. Let us see the responsibilities or services of transport layer. First one is process to process delivery. Already we discussed it. Second, multiplexing and demultiplexing. Multiplexing means transport layer sends packet streams from various applications simultaneously over the network using port numbers. So all the packet streams are sent simultaneously. Packet streams means streams of packets coming from various sources, hundreds of sources. Demultiplexing, it is the reverse of the multiplexing. The packets are recovered and delivered to the appropriate process running on the receiver. Congestion control. Congestion occurs in the network when network is carrying more data than it can handle. The traffic is more. Congestion occurs. It results in waiting delay and also loss of packets. Some packets may be lost. So they have to be retransmitted. This further increases the congestion. Already congestion is there and you have again retransmitted some packets. It results in enhancing of the congestion. Transport layer uses open loop congestion control to prevent congestion. So proactive and reactive both methods it will take care of. Proactive methods, prevention by open loop methods, and by using closed loop methods, control, that is when congestion occurs, how to remove. It bothers about those methods. Flow control means it is the process of managing the data transmission rate. Suppose receiver is slow, sender is fast. Receiver can't receive the data properly. In that case, receiver has to inform the, if flow control is there, receiver informs the sender, please slow down or stop. Right? That is, whenever there is a data transmission between two parties with the different speeds, we need flow control. Error control and data integrity. Error control in transport layer is achieved by error detection codes, checksum, and retransmission process. This ensures integrity of data. Integrity means accuracy of data, consistency of data. Transport layer primitives. Primitives refer to operations. So listening, connecting and disconnecting, sending and receiving. These things, let us take them in order. Listen means server is when the server is ready to accept a request from one of the clients, it puts this listen primitive into action. That means it waits for the request. Connect. This primitive is used to establish correction. Correction with the waiting pair. When a client wants to talk to server, it executes connect primitive. Then two things happen. First thing, a connection request is sent from the sender. And when it is received by the receiver, a connection accepted TPDU, acknowledgement is sent back to the client. Thus the connection is established. Receive means receive primitive simply waits for incoming message. When client sends some request, it waits for the reply. Similarly, send, client puts this primitive into action. This is simply used to send or transfer the message to the peer. Peer, I said, peer means a thing of equal status, a person of equal status. Here, clients and server. Here also we use the term peer-to-peer. Then disconnect, connection is to be terminated or ended. It has two methods. The first method, asymmetric variant here, either of the transport user, one of the user issues a disconnect primitive. Then the connection is released. Second one is symmetric variant. Connection is released when both sides have a disconnect. Both parties sends this disconnect request. QoS parameters. Quality of service, it is the description or measurement of overall performance of a service. Performance in the sense, in the view of users, seen by the users. Performance seen by the users. So, if a service means it may be telephone service, computer network or any other service. Business service also. QoS can be quantitatively measured using some parameters. We discussed below some 6 parameters. These are applicable to the TCP protocol, also UDP protocol, transport layer, TCP protocol. Only thing is, the last one will come to it. It is only for UDP protocol. First one is packet loss. When packets are sent from source to destination, one or more packets may fail to reach the destination. That is, they are lost. Why this loss occurs means due to congestion of network, software problems or hardware problems. Any hardware issues may be there or software bugs. 1 to 2.5% packet loss is acceptable. More than that is, we have to think. Some packets are to be retransmitted. Latency is some sort of delay. It is time taken for a packet to travel from source to destination. Ideally, it should be 0. If a voice over IP, VoIP call has a high amount of latency, it involves both video and audio signals. It experiences voice over audio signal mainly. It experiences echo and overlapping audio. Jitter. Latency is the time taken by packet to travel from source to destination. Jitter is the variation in latency. That is, the latency is quite inconsistent. Then we say jitter is said to be occur. Jitter is due to network congestion or any route changes. If there is too much jitter, video quality suffers. It degrades the quality of voice and video communication. It can cause flickering of display monitor and data is delayed. Transmission is delayed. Availability means availability of network, availability in the sense it should be able to connect quickly. Whoever is the authorized user, he must be used, he must be, he must have quick connection to the network, right? So ability to provide a quick connection to the authorized users is the availability. Availability also is responsible for integrity. It is measured as a percentage, average percent of the time during which the network is performing its intended function. The last one, see, minimum arrival time, maximum arrival time. These two are for UDP protocol. UDP in the sense, UDP is connectionless. We don't know when the message arrives. Delivery of message is not guaranteed. So in this case, minimum arrival time, average arrival time are also used as parameters, QoS parameters. Then user datagram protocol. UDP is a connectionless datagram service. Connections means delivery of message is not guaranteed, it's not reliable. It is not reliable, but why it is used means sometimes an application needs speed, not reliability. In that case, it selects UDP. That means in time sensitive applications, we discuss a few applications, mention the names at the end of the topic. UDP packet is called datagram. It has a fixed size of header. 4 fields, each field has 2 bytes, totally 8 bits. So this diagram is header and data. Header is 8 bytes as I said. Only this header is taken again and shown here. 2, 2 and 2 plus 2, 8 bytes. So first 2 bytes for port numbers, application numbers of source and destination. And this byte is total length, this byte is checksum. If error correction is needed, checksum is optional. Here, this point I would like to stress. Why checksum, why error handling, why error correction in transport layer? Say when you are using UDP, in case of UDP or transport layer in general, already error correction, error handling is taken care of in the data link layer. It is a job of data link layer. Then why second time it is needed means, if it is 2 times, it is more better. That is a general answer, but it is not just the full answer. One thing, data link layer handles the data as frames. This handles as, transport layer handles as segments. One thing. Sometimes data link layer may not perform error control, even flow control. For example, if in data link layer we use the protocol, simplest protocol, of course it is obsolete and rarely used. If that protocol is used, no error control is taken care in the data link layer, then in UDP it is better to be taken. So it is optional when you are performing a error control activity checksum is used. Source port number, I mentioned 16 bits, I already told you length. UDP services, process to process communication. Connectionless service, both were explained. Flow control, when source and destination are with different speeds, how data rate is to be handled. Error control, there is no flow control here in UDP. Error control, optional, only provided using checksum. UDP checksum calculation. This involves three sections: pseudo header, UDP header, and data part. Data coming from application layer. Pseudo header is part of the header of IP packet. In IP packet, we are encapsulating the datagram. So, pseudo header is the part of the header of the IP packet. Some fields are filled with zeros. The upper black color one is pseudo header, lower one is header. Header we already discussed. Here padding means adding zeros to see that a fixed length is maintained. Coming to pseudo header, it has also source IP address, destination IP address. Some fields are filled with this field, some zeros are filled. Then this is 8-bit protocol. What is the upper level protocol used? And this is total length of the 16-bit UDP. Applications, typical UP applications. These are good applications. So I already said UDP is unreliable, but it is used. When it is used means, example, VoIP, voice over IP. Here speed is important, but not reliability. So when flow control and error control are not important, we are using. Second thing, when there is already a process, has already flow control and error control, it is quite suitable, such as TFIP, trivial file transfer protocol. Trivial means insignificant, small. Multicasting, that is one source and multiple destinations. Video conferencing, used for management processes, used by management. Simple example is simple network management protocol, SNMP, used for some route updating protocols. RIP is the example, routing information protocol.